Now the association between the CDR. Now what is CDR? Complementary determining regions which are present on the antibody structures, and the monovalent antigen. The monovalent in the sense it has a single binding capacity to the particular antibody on the antigen, which can be expressed as an equation given here as antigen reacts with the antibody and then give rise to antigen and antibody binding sites and whatever. So the K1, so the one which is being bounded antigen and the forward reaction, what we call it as K1. So that is your association rate constant. We also recognize it as a association because there is an association between the antigen and antibody that gives rise to association rate constant. And there is another reversible. Anyway, these two bindings are quite reversible to each other. So the reverse thing, that is a dissociation of an antigen antibody complex to a free antigen and antibody, we call it as dissociation rate constant, which we designate whereby K1 by K2, when you take the ratio of association constant to the dissociation constant, what we call it as Ka, that is your equilibrium constant. It means the overall antigen binding to the antibody is all determined by the equilibrium constant. So when you take the equation according to the rate equation, the rate of chemical equation, chemical kinetics, now we can express equilibrium constant as the ratio of the concentration of your bound antigen to the antibody divided by the concentration of free antigen and the free antibody, which is nothing but K1 divided by K minus 1. The values of Ka depend on the K1 for small haptens and K1 is high for a large protein antigens. Now K1 is lower. Now calculation of this dissociation constant. So when you take the reversible, so when you want to find out the dissociation constant, this is your association constant. Whatever we have discussed, that is Ka. This is when they associate antigen and antibody to form the complex of antigen and antibody. Now dissociation constant, when this complex dissociates back to the antigen and antibody, what we call it as Kd. That's nothing but dissociation constant. It is just reverse of Ka. So where we take the ratio as concentration of antigen antibody divided by the bound antigen antibody, which is nothing but K minus 1 divided by K. This is how we can measure the affinity, to what extent a particular antigen will bind to the antibody. Now overall, an antigen and antibody is said to be strong when its dissociation constant is greater. It has to dissociate back to its antigen and antibody.